All right, so as you guys know, I'm going to be talking about game engine architecture and something that's a part of game engine architecture, Nvidia PhysX. I'm sure a lot of you have heard about it in the new and latest, greatest games. It's pretty cool, and it's my contact information. We'll get to that later. So, introduction. What is software architecture? Well, when you graduate and go into different programming industries, the first thing you'll notice is that the stuff you work on or the stuff you program is about 1,000 times bigger than any project you've ever worked on at school. And one of the most important things, the first things that you learn when you get into a new job is how is that big, huge program that you're going to be working on, how is it organized? What are the structure of, if you're talking object-oriented programming, there's probably thousands of objects and classes. How do each of them relate? What do they do? And really, that's what software architecture is how are these different things structured? And on the flip side, what is a game engine? Well, Wikipedia says it's a software program that is designed for the creation and development of video games, which to me is only part of it. When you play a game, the game engine is behind the scenes. It's running the game. So a game engine really is the foundation for anything that has to do with creating a video game. Or, in the movie industry, you would call a game engine more of a pipeline because, you're outputting frames for a movie. So really, it's all the same thing. You have an artist, you have a game designer, and the end result is, or you have a director, and the end result is either a movie or a game. So game engine architecture, put the two together. How is the structures that create this game or structures that create this movie, how are they organized? And that's kind of what I'm going to cover. I'll just give you a list of stuff here. No use in talking about it because I'm going to be talking about it here pretty soon. Going to talk about layout of the architecture and physics. Going to go into the game loop and do some Lua scripting and stuff. So I'm going to be referring to this throughout the presentation. This is a high-level kind of picture of the architecture. Most jobs, when you get there your first day, they will draw you some crazy bunch of squares and say, here's what this is, and expect you to know exactly what's going on. Not really. But here, I'm going to talk about physics first. So this is the engine core. And you can see here we have OpenGL for kind of graphics stuff. And this works with the GPU. And then we have physics here, which works with both. It works on the CPU and in the GPU, and it varies depending on what you're doing. So we'll talk about that in a bit. And then over there is the Lua virtual machine, which I'll cover later on too. But the main thing we're going to focus on right now is the engine core and physics. And the engine core is what you would consider your standard C++, project with classes and different entities and things. And what we do is we have a bunch of things that we call managers. These managers are our implementation of the tools that we use. So for example, for physics, we have a physics manager. For Lua, we have a Lua manager. And for assets, like 3D objects and all that, we have an asset manager that contains all of that stuff to kind of iterate through if we want to iterate through all of our objects and tell them to render, things like that. And then we have, in the future, an audio manager, which contains sound objects for us to play. And really, it's just our implementation of the following stuff. So all of these managers are contained in what we call an engine manager. It's our highest level thing. It's where everything comes together. It's our ground zero for where all of the functionality goes. And that allows us to expose that one class to other programs, other things, and we centralize all of our functionality there. So, which I'll get to later. But like I said here, the physics manager is our implementation of what NVIDIA gives us. So you go on the NVIDIA website, you download the SDK. It comes with include some header files, some libs that you link to your project, and those header files contain stuff for them implementing things like cloth, fluid, joints and springs, force fields, just about everything you can imagine. And the reality of it is, if I want to make a game that's any good, like, well, I shouldn't say that because there are simple games that are really good. But if you want to make a game like Unreal, and you're just by yourself, maybe with a couple buddies helping you, do you really think if you want to have cloth in your game, you can implement that stuff on your own? No way. It takes way too long. There's hundreds of different things you have to implement. So what has happened is all of these indie developers have been using these kind of libraries, and it allows them to have cool effects without, like having blood and sweat all over their computer from implementing it. So some physics principles. We'll go over lesson 101 of physics. And really this covers about, I would say, 60% of what physics does for you. There are three things. There are scenes, there are actors, and then there are forces. You can have dynamic actors, which are these guys, these shapes, and they can be moved around and interact and collide with things that are in the same scene. So you have a scene, that scene has gravity, and then you throw a bunch of things in the scene and they all interact together. But because this is run really fast and there's often like hundreds of thousands of objects, you need to have very concise meshes. Like they can't be very detailed because that takes a long time to compute. And because you're doing this 60 frames a second, it needs to pump out this stuff. And so that's why the poly limit is low. So it's like a character or an object. The static actor is something that doesn't move around. It's this ground plane you see here, for example. And that can have lots of polys, but it doesn't run. So here is a little example from their SDK. And you can see that all these things exist in the same scene, right? So and the scene has gravity, so you can immediately see them fall here, and they interact with each other. You can move the box around and add forces to it, and they collide with other things. So that's a force. Now, this is what physics sees. In a game, you don't see this collision mesh, right? You may have this cube may be a teapot, and you may want your teapot to not. In a huge game, you may not want your teapot to roll around. You may want it to just move around like a cube. So you surround the teapot with this collision mesh, and then physics does all the calculations with all these stuff for you rather quickly, as opposed to having a very detailed detailed teapot where you have all these like curves and stuff. That takes a while. So that all depends on what your game is, of course, and the kind of collisions you're going after. There's a lot of decision that goes into the details here. So what happens here is an example of the physics manager. I tried to make the code as big and readable as possible, so it might not be exactly right here, but in terms of font, but you can see it, right? Can everybody see it? Okay. So you can see kind of the functionality that we're exposing, and if some of you see a type here, like NX scene, you're like, what the heck is that? That is something that is exposed from the SDK, from NVIDIA. So you get a bunch of header files that have all of these different types, and I just told you, what a scene was, right? So there it is, scene right there. In game programming, you try to use pointers as much as possible, so you're not passing bunches of data around everywhere. So we have a bunch of functions here that we want to execute the physics. So we have all of our actors and stuff, and we say, okay, physics, do your thing, and process all of the collision and stuff. And we give it you give it a time period, an interval, and then it calculates a bunch of collision. And then you want to get the physics results. When physics is done, you say, hey, give me all the collisions, and you update all of your objects with the transforms and the rotations and all that stuff. And then we have a bunch of little things here. If I want to add a object, now this is one of our types, our generic object. You wouldn't know that, but it is. And this is when we want to add a object to a scene. And an object has one of these guys in it, a physics object. And a physics object has the actor. It has descriptions and stuff for physics to create that mesh. So what this does is it allows us to isolate our implementations of the different tools that we have. So, and this is a game loop with physics. So we take those functions that I just described, and in game engines nowadays, the big deal with these kind of game loops is concurrency, right? You want to be able to things that are independent of each other. So when you render, when you draw something, the physics doesn't need to be, the transformations have already been done. You know the rotations, you know everything. You just need to draw it. And so you tell the GPU, you say, hey, draw everything. And that's here on render, is what we call that. And then the physics is totally independent of that. So what we do is we tell the physics to go ahead and do all the physics simulations. And while it's doing all the physics simulations, we're going to tell the graphics card to render. So there's two things that are kind of going in parallel that really make this kind of stuff possible. Because there's no way you could render your entire scene and then do the physics one after another for like a real game. So, and that's the whole advantage of having parallel processing and all that stuff. It allows you to do some of this. And when you get, you can add other things in here too, like sound and other things that are independent of each other. And so we tell it to execute the physics. Up here, we have, this is our newly added, this is like a month old, like a events class where we can send out events to Lua. We tell physics to, so it runs here, it runs the simulation while it renders. And so once it's done, we have to get the results. So we get the results here. We call update, which sets all of those results to the actual objects. And then we tell it to go again. Just rinse and repeat as fast as you can. This is incorrect. This is supposed to have a time interval, but we're not quite there yet in the implementation. So, and also here, you can see I have an array of scenes. So you can have multiple physics scenes, but you have to run the simulation on each one. And for now, since we're doing testing, we only have one scene. But imagine having a bunch, maybe in your game you have, like it's an RTS where you have guys running around on the ground, but you also have ships flying around that you don't want the same kind of gravity to act on them. Or maybe you have particles that you don't necessarily want to interact with everything else. It's just an effect, right? You just want a bunch of particles to stream out and look cool. You can put that in a separate scene with its own thing, and it won't collide with things in other scenes. So kind of gives you a bit of power in terms of a bit of control there. Oh, but first. So with all of that implemented, here's another example from the SDK. You can have all kinds of different cool things. And, oops, you can see here. You can see a different collision you can do. Oops, I missed. But with a physics engine, it's really hard because it's not like real life, right? You can have stuff appear out of nowhere, and you have to define interaction for stuff that appears within something. So you can see it's struggling there. This laptop doesn't do hardware acceleration because of the graphics card, so that's why it gets choppy. But you can kind of see how many things you can do, and that's kind of the power of this SDK, is it's pretty efficient for doing all of that stuff. So, and this exercise is all of the stuff I've talked about. If you had, if you really wanted to, you could take with what you have here and implement that and do that. So it's not too bad. So back to the architecture. The next thing I want to cover, so physics is just a part of it. You can, I mean, that's the basics, that's it. I mean, with that right there, you can implement a game with basic physics and be totally fine. But, you know, that's just a piece of the pie. So the next thing I'm going to cover is basically, I'm not going to go into, you know, this is a whole lecture in and of itself, right? Rendering. So I'm just going to briefly cover this. We use OpenGL to do our rendering with some CG shaders, which is another Nvidia thing, but you could use DirectX shaders or OpenGL shaders or whatever, it doesn't matter. The GPU, one thing that's kind of important to realize is this is interchangeable from the rest of the engine. It can be totally different. All the engine cares about is calling render. If you call render on a Wii, if you call render on an Xbox or a PlayStation or a phone, it does not matter. As long as you have this underlying implementation of render, that's totally fine. So that's where you get, like, World of Warcraft is on the Mac and on DirectX and on Windows. Like, this right here is different on both. And probably they have some give and take of what's the same. So that's that. So here is the engine's kind of implementation of an object. And you can see here, here's our object. We have, you know, we pass it a mesh, a material, some position stuff, and a Lua file, which was supposed to be AI, but I think we're going to change how we do that. So, but it just shows you kind of stuff we pass into it. Update and render. Those are the two most important things. And then some details here with, here's the physics object I was telling you about. It takes a collision mesh. So that's the mesh that describes how they collide. And then here down here, I don't know if you can see, but we have a vector of other objects as components. So what that allows us to do is we can have an overlying parent object, and then we can iterate through its children and call render. So you could have a tank, right? And then that turret is separate from the tank. It moves and does all kinds of different things, but it's part of the tank. So that can be a separate object. And then the wheel tracks can also be a separate object. So what that allows you to do is kind of have a component, they call it a component-based design. It allows you to make objects that consist of different components. And it's commented out because we're not quite there yet. But you kind of get the idea. And so up here is kind of how we call render. So our render component is probably where we could interchange stuff with a little bit of matrix adjusting for OpenGL and DirectX, because their matrices are a tad bit different. But here we just tell the render component to render, and the render component has all the OpenGL code. So we won't go into that, though. But you can see here where you would iterate through all your components and tell your components to render. You say object render of all your components. So that is that. So back to our picture. We've covered all of this area here. And really all that's left is Lua. So we're going to talk about how the engine works with Lua and how it implements Lua. And this is probably by far my favorite part, believe it or not. This is the reason why we're able to do a lot of what we do, is because Lua is there to kind of expose it. So when you make a game, you know, you have your game programmer, you have your game designer, you have your artist, you know, you have all these different people. And the goal of your engine and the goal of your, you know, software should be to let the artist get as close to the result as possible. So you have an artist who draws, you know, a piece of concept art, and he wants to see that concept art in your engine. Well, no matter what, he's going to have to model it. So he goes in there and he models it. Well, what does he do after that? Well, he needs to put it in your game. And if it has a bunch of components, if it's a tank and it has a turret, you need to define all that stuff and blah, 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 blah. Well, you don't want him to have to go in there and program everything. You want him to just be able to, make his model, put it in your, program and say, here's my model. And it should show up and work. And he should see what it's going to look like in your game right away. There's no reason why he shouldn't be able to. So that's kind of the goal with this architecture. And you'll see that in a bit. So here is our Lua manager. And this Lua state here is something you get from Lua's source code. You can get it totally for free. Everything I will show you here, you can download and use completely for free. And you can use as a commercial stuff too. You can, ship it with your game. You can ship Lua for totally free, no charge whatsoever. So there's no excuse to not use it. So here you can see Lua state. If I want to, here's like a getter you can kind of see, and then here's if we want to run a script, we pass it a string, which is the file, and then we have our little path for where our scripts are located. So we, say, hey, here's where the script is. So we don't have to, when you say run this script, you don't have to give it the full path. So I don't know, it's kind of cool. But anyways, so then this Lua state is the environment for which your stuff acts in. So you say, in Lua, you say X. You don't say int X. You just say X, which I know for you is like blasphemy, but just bear with me. You say X, and then in this Lua state, it stores X. So you say X equal 5. So X equals 5 in this Lua state. If you have a different Lua state, then X doesn't exist. You see what I'm saying? So they're different environments. So that gives you a lot of power, again, in concurrency, is you can run multiple Lua states, although a lot of people say that's not really needed. It depends a lot on what you're going after. Pretty basic. So Lua has different ways of interacting with C++ in terms of different types and stuff. But mainly what it has is a stack. And you take a number. So here's up these two lines up here. These are API things that are provided from the include file when you include it. This function pushes an integer onto the Lua stack, and the integer in this case is game state. So it pushes a number onto the stack, and it tells Lua to set that number as a global. So and then you give it the name of what you want to set it as. So I say game state. So if game state equals 0, it's going to push it on the stack. It's going to say, hey, Lua, set global, and Lua's going to pop it off the stack and set it as game state equal whatever you set it to. So, and then here you can see I'm running a script, grav core Lua. So that contains the event stuff, because I'll get to that later. But we have an event system that is totally done in Lua. And I don't know if any of you do anything besides C++, but in C#, in Java, in a lot of languages, you have these events where you can add listeners and you can dispatch events. In Lua, I implemented that entire concept in about 30 lines of code. So it's extremely, extremely, extremely powerful. And it makes it really easy to kind of extend. So you can see here, this is the engine manager. Remember I said that this is where we expose all of our functionality. Everything that you want to do with the engine, you do it through the engine manager. So here you can see, this is kind of details, but I use Luna is a little template class that you can use to expose your things in Lua. Don't worry about it though, that's details. Basically, I give it a list of functions. So load asset, create asset, release, and new event manager. These are C++ functions in the engine manager, implemented in the engine manager. I give Lua a engine manager string that defines the name of the object, the type. And I give it a bunch of functions that describe, here's the kind of stuff you can do with this type. So kind of details, it definitely is not cut and dry right away to understand how this kind of stuff works, but it's extremely important because the interaction between C++ and Lua is kind of, without that you can't really do anything. But with it, you have to be careful because it's not very fast. It's kind of slow to pop and push values on the stack. And now when I say fast and slow, you have to go at 60 frames a second, so you can't be popping and pushing like entire classes on. We do this in the very beginning at startup, and that's it. This is kind of the init stage, so it's not that bad. But it just kind of gives you an idea of what the interaction is. So back here. So we took care of the engine core. We took care of all of the underlying components. Now what can we do with all of that, right? We have kind of the virtual machine that was over here. This takes Lua script and processes it on the CPU. And the Lua up here is where all of that exposed functionality gets represented for the game and for, in our case, an editor, where we create objects with a nice fancy interface, which I can show you maybe next, I think. But so anyways. So how many of you have programmed in Lua before? Not a single one. Yeah! All right, your first Lua script. Look at that, huh? So I would do hello world, but that is like so incredibly simple, it's not even worth it. So you can see here where I say print object something pressed. There's hello world right there, all right? So ignore kind of the types, because I told you a lot of the stuff like gravcore.lua has already been executed at this point. So you see thing like EM, that's our event manager. And then I gave it a function here, and then I just call the function and you pass in stuff. And you'll notice that it's typeless. So I just pass in this thing called obj, and Lua is supposed to know that. That's kind of dangerous and a little bit, but at the same time, you're the programmer, you're supposed to know what you're doing, and if you don't, well, that's your fault. So, anyways, so here, what this is now is this is something that, this is really important because this allows us to define data at runtime, which a lot of you may know that when you do a project, if you define any type of data in your project, a lot of that is done hard-coded, and it's done when you're coding, as opposed to you compile, you run your project, and then you give it your data. So that alone is extremely powerful because you can go in and you can create infinitely different meshes, infinitely different objects just by editing a Lua script, as opposed to hard coding, compiling, and blah, 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 blah. And when you get to really big projects, like Unreal Engine, it takes half a day to compile. So you really can't hard code it much. So anyways, some basic things. You can see a comment here. You can see one here. It's 2 dashes. This is a Lua table. This is how you do things like object-oriented programming and stuff. Lua doesn't come with any of that, but like I said, it's so powerful. Like you can implement object-oriented stuff in like 20 lines of Lua. So it's really not a big deal. And maybe after I can show you kind of some of that stuff. But you can see there's no curly braces for functions. It's like you say, here's a function, and then here's end. What else? Here's game state. Remember I was telling you about game state? So I set it before, and now you can say like, oh, if game state equals something, whatever. By the way, this script is horrible. You can see I'm setting it equal to 1 and then checking if it's equal to 1. This is more of the sandbox script. It's not really meant to, it's kind of meant to test different functionality. But engine manager, where's engine manager? Here you go. So here's where I'm calling something for engine manager, create asset, remember? So I'm passing in a bunch of stuff here. So I have defaults. So over here, defaults. So cube, this is the default table for a cube object. You can see I'm describing a path to the mesh, path to the texture, normal map. For rendering, you can give it a mass. You can give it a number for which scene you want it in. speed, max acceleration. So also what we have done here is we have differentiated the engine from the game logic. So you can see here we have a bunch of different properties that, our goal is to implement the entire game in Lua, right? So this game has no knowledge of anything here. It doesn't care. All it cares about is Lua. All of the functionalities, all the objects are represented in Lua, and Lua keeps track of objects by an ID. So where is it at? Up here. Load asset is over here. Yeah. So you can say, so cube object dot type. So this is, is it a cube? Is it a ship? Or is it whatever? So we say, engine, we want you to load this kind of asset with those meshes and everything. And we're going to pass it the table that describes all that stuff. The engine will pop these paths off the stack, Lua stack, and load the mesh, load the normal map, load all the stuff. And then, so that's at load time, right? When you're sitting there waiting for your game to load. So then at runtime of your game, well, not really, it's all runtime. But when you're running your game, when you're running around or whatever, and you want to create a ship or you want to create a guy, you call create asset. And you pass that type that you were given. So then the engine knows what kind of type of thing you want to create, and then you give it a position. So that's kind of the basic concept that we kind of have gone with for using Lua to do data-driven things. And in game design, that's what it's all about. And really the coolest thing about all of this is that all of our game logic can exist within these kind of event handlers, right? So any kind of, now I've been calling these objects, right? But later on, well, we'll get to that later. We'll just go to the next one. So here is a picture of kind of what we can do with this, right? This is a picture of an editor. Let's see. I think this is 2 months old, maybe. This is done in C#. You can kind of see these fancy little WinForm kind of, tables and buttons and things. This is what you want your game designers to see, right? Except, unfortunately, this is really unintuitive. I was just trying to get this to work. So getting it to look nice and pretty and be nice and easy to use, that comes kind of after I was trying to get it to work. I don't know if that is kind of a good thing to teach, but so you can kind of see here. What I have in C# is something called Lua Interface, and that allows C# to interact with Lua. So using the same Lua state from the engine, I propagate that same Lua state all the way up to C# and all the way to Lua Interface, and it stores that environment for the editor. So what it allows us to do is it allows the editor, which is a totally separate application from the engine, to interact with the engine via Lua. So what does that mean? That means we can come here into this nice fancy little list view. We can type in, here's my path to my object. Here's my, path to the normal map. Here's the, that's wrong, actually. So ignore that. But type is, and you say, okay, I want you to load this asset. So the engine, over here you can see the output. Blah, 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 blah. So engine manager, load asset. So it says load asset. Oh, I got, the path. I got all this. It says load asset finished. So then the next thing you want to do is say, hey, I want to create a cube at 25, 25, 10. So I give it the XYZ up there and I say, create. And it takes that cube and it creates it at 25, 25, 10. So you can see the first one I created was at 0, 0, 10, which is the one right in front of us. And the asset manager says, oh, I'm creating an object of type 1. And it says engine manager is creating an asset, returning unique object ID. So you have an object type, and then you have like 50 of those objects, right? And you want a unique ID for each object for the game. So if your soldier 1 takes 10 hit points of damage and he gets shot, you need to know which unique object it is. So that's how Lua refers to that. So if you notice, the only interaction between Lua and the engine is through integers. We don't do anything else, just it passes one int into a function and maybe a little table at load time for some data that goes with it. It's very, very minimal. We don't want to be pushing tons of objects on there. We don't, even pointers, we just, one integer and let the engine take care of the rest. So that is kind of the strategy for this architecture stuff. And here is kind of some other things you can use that do exactly the same kind of concept. So PhysX is one physics engine, but you also have Newton and Bullet. Those are open source things. Some people are open source fans. And actually, a lot of people in the industry say that it's a good thing to contribute to these open source things because you can put it on your resume. You can say, oh, well, I did fluid interaction with turbulence in Bullet. And some game designer who uses Bullet will be like, whoa, we use that. And that's kind of good stuff for your resume. But that applies to all kinds of stuff. So with sound, you have Fmod and you have OpenAL. Those are the two. There's more too. If you go on Wikipedia, it'll list like 100 physics engines and then like 100 like sound APIs. But these are just some of the popular ones. So Fmod's the same thing. You can go and you can download their SDK. You can derive like a sound object and all your high-level implementation and do the exact same thing that I just described. And same thing with OpenAL. And one thing about Fmod too is they brag that, oh, you can use our sound stuff for consoles. So some of this stuff is console dependent. So you have to be careful there. But so scripting, you have Lua and Squirrel. There's a ton of other scripting languages out there, but these are the two that I've seen a lot. And you could have Python in your game engine, but I don't really see that a lot because Python is the virtual machine is huge. So compared to Lua. Lua is only 220 kilobytes. It's very, very tiny. It's like 17,000 lines of code, which is probably a lot to use, but never mind. So then networking, you have RackNet. RackNet's really, really cool. I suggest if anybody is at all interested in networking stuff, you can go download it, you can check it out. He does everything you could imagine that has to do with connecting two computers for whatever. He has server implementation, patch implementation, NAT. You hear about NAT firewalls. I don't even know what that is, but RackNet, he takes care of it for you. He gives you all these nice little implementation things. You can see the source code, and that's all taken care of. So, and it's free for indie developers. All this stuff's free for indie developers. And indie means it's free until you make lots of money. Then when you make lots of money, you have to pay them a little bit. So for rendering, this is kind of iffy because Ogre and Ehrlicht are very popular, but I'm not too sure because I haven't worked with them, but Ogre and Ehrlicht take care of all of this stuff in one way or another. And I think they implement PhysX, Newton, or Bullet. They might implement them all. Who knows? But yeah, that's kind of stuff you can use for things like AI and animation, things like that. Really, you're kind of left. You're not necessarily left for dead. Of course, there's things you can use, but these are kind of the big guys in terms of things that you need, possibly. So, other resources. GameDev.net is a really great forum. I've been using it for 2-3 years now. Check it, I guess, religiously. But where that Shader X book, is that around here somewhere? Can somebody hold it up? The editor for that book is on here frequently. He worked for Rockstar Games, worked on all the Grand Theft Autos, Grand Theft Auto 4, and occasionally he'll chime in about a question somebody has. I mean, mainly if it's a question about his book, he'll go on there and answer it. But anything else, he just kind of ignores. But there's really good people. There's a guy from Blizzard, from their OpenGL department, who's in the OpenGL part of the forum. So there are really good people in there, and their usernames are names you have no ideas. Like that guy's name's Wolf. So you see a guy in there named Wolf, and the last thing you think is like this 50-year-old, really senior level tech guy, right? It's like really weird. But anyways, and developer.nvidia.com, you can get a lot of the SDKs from there for everything from shaders to physics to their newest thing is Nexus. It allows you to do debugging for shaders, which has always been a pain. But you can go there to get stuff. And then Industry Broadcast is actually really cool. It's a new podcast thing that allows you to go on, and this guy updates his website every couple of days usually, but does podcasts of different things in the game industry. Everything from how to start a game company to how to program networking to how to write a good story for a game. And he has like 100 and something posts, so it's enough to keep you busy. But that's my contact info. If you have any questions, you can send me an email. This is our team name and our blog, or / my blog, where I try to post updates, although I don't really update it as much as I should because I am extremely busy, but I try. And so that is it. Yeah, I have time for questions and show you. There's a couple other things I wanted to show you actually that aren't really presentation related. But how I was telling you, so this is Visual Studio, by the way. And you can see some of the things I was talking about. Here's the engine, here's our editor, here's Lua Interface. This is what connects Lua to C#. Can you guys see that okay? Yeah. So what I was saying when you do define data in Lua, so if we go to our content thing here and go to modules, core. Oops. So here you can see kind of the core things we've done for Lua. So if we go to camera, for example, we have our base camera, right? But we also have a free camera, a RTS camera, preview camera, maybe a cinematic camera. There are different kinds of cameras, right? All of that can be defined in Lua at runtime. The engine may need for very few, so like in the asset manager, you know how we had the object iterator? We'll make a camera iterator also, and that is put where the cameras are. And then whatever camera is active, is what camera gets used to render. So, but all the cameras need to be updated because you have cameras flying around and all that stuff. When you go to use the camera, it needs to be in the right spot. So it really allows us to do things like this. And then if we go to, let's see, if we go to lights, we have all these different kind of lights in Lua. And in the editor, all you want to be able to do is go to your list and say, give me a directional light here. And then the editor says to Lua, hey, give me a directional light, create it, and put it XYZ. And your game designer goes and creates his level and then says save, and it saves a Lua file of defining all of that stuff you created in the level, and then you're done. So yeah, that is all. Yeah. Any questions? Now that your minds have been blown? Anybody? Yes, absolutely. I can actually send it to maybe the CS Club thing or something. Everybody can get it. I know there's a lot of stuff in there that's really valuable, so I was planning on that.
You began telling us something about Lua, and then something
Right. Well, I can show you what Luna is actually. It here. Oh, by the way, this is our project. These are all of our files. You can kind of see it's.
Are there some cool effects that you can show?
No, because I've ripped the engine apart for implementing cameras. So, let's see. So, you can kind of see here. Full screen. So, here's an example. The Lua community is really nice. Like, a lot of people develop these things and just totally put it on the internet for free. Lua Interface was one of those. So you can kind of see here is this similar thing I showed you in the presentation, where you list the class name as a string and then the functions for it. This guy does it without the macro, so you can kind of see the function pointer for a class, which maybe some of you haven't quite gotten to yet, but you can see some other. So here's the implementation of it on the C++ side. So that's an older version which doesn't work. So here you can kind of see all of it manipulating the stack. Lua has these things called metatables, which are really interesting. You can define how it's like operators, but it's in an array. It's in a array as opposed to being like an operator. So you can create all kinds of definitions for how things interact and different things. But yeah, you can see the C++ integration for Lua is fairly large, but I'm a big believer in, things are designed for specific reasons and you should use them for that reason. You shouldn't use C++. Like, you can download this thing called LuaBind, and it's hilarious because every 3 weeks you go on the game dev forums and somebody has a question on how to use LuaBind. Nobody knows how to use it. And it's because they are relying on this high-level implementation in C++, and they don't know how it works on the low level. And if you don't know how to use the stack for Lua and something goes wrong, what are you going to do? You don't really know. Luna sits kind of right on top of the stack, and it sets up different things for you, very low level. And when something went wrong, it forced me to kind of look at the low level interaction, and it actually forced me to learn the stuff as opposed to just posting on the forum, how do I get this to work? So that's kind of one of the reasons I kind of support it. So and this implementation will be large, lots of lines of code, but it just makes Lua more powerful, which is what you're after. So.
So what's next? You say you showed us some stuff that didn't quite work.
So yeah, I'm getting married in a month, so the time for this kind of stuff, yeah, that makes sense. But the time to get this nice and pretty for the talk was kind of, the fiance had a lot that needed to be done. But one thing that's kind of important, which I can't show you, I don't think I have an internet connection, is Perforce, but don't really have enough time for that. It's okay.
But what's next in terms of?
Oh, in terms of this, well, I have this nice architecture all laid out, and Matt Ford and I are and Brian maybe, depending on if he has whatever, if he chooses to help us. We just sit and we're just implementing all of the stuff you saw. So if I show you let's see, here we go. So if I show you directional light, this is just a comment, right? Free camera is really the only thing that I've implemented. But you can kind of see move cam, engine manager move cam. I don't think I saw that in the header file, so that doesn't even exist yet. So just kind of going in and fleshing out the implementation of all of these different things to make them real. But you saw the picture of the editor. It works, and it's just kind of like a proof of concept that it works, and yeah, just kind of implementing. Well, 3D graphics is 3D graphics, and games are games, right? That's one thing I was telling Dr. Khrushchev before this talk. All of the things like Flash and even Java and JavaFX and Silverlight use this exact same architecture. You have your low-level Flash player. You have ActionScript, which is kind of your thing for defining your different data and whatever for you to program. And then you have something like Flex, where you have all of these implemented things like a list view and all of that. So it's a very popular architecture because it separates different kinds of purpose. So.
Well, thanks very much. We need to stop there, but Dr. Stauffer?